On the northern end of the swamp, we see here at the Okefenokee Swamp Park, we're on the very edge of the swamp. What you see behind you is an area that is usually flooded, but because of the drought, so to speak, it's a sort of a drought. We don't have any water at all back in here now. But look at the size of these trees and the composition of this forest. These trees, as you can see, are extremely tall. These pine trees are 110 to 120 feet tall here, and some magnolias and some bay trees. So these have been here quite a while, and a very large maple right behind us here. A very large maple tree is hanging out over the water. Down below here we see a dry environment, perfectly dry right now because it's been a long time since any rainfall. And then looking at the composition, we have pine trees, obviously. Then we have back here, we have bay and gum. That's a black gum tree back there. It has the vertical ridges in the bark. Down below, we have little magnolia trees coming up. These are Magnolia virginiana, small magnolias coming up right here. These are bay trees here. Bay trees, like this age, are probably the result of a fire that happened in '54 and '55. And these now are about 30 or 40 years old. If you can see behind you, the forest here is only about 30 or 40 yards wide. Then there's a blank space out there. There's a huge break. That was a fire break. It was cut for the fire of '07. And this is because the fire was getting close to the park here. So the forestry people came in and cut about a 50 or 100 yard clearance. They cut down everything within 50 or 100 feet of the park. And it all fell back there. So today you can see way out into this blank fire break. But slowly it is recovering now, 10 or 12 years, 15 years later. It's slowly recovering, and we see the ground cover is now coming in, shrubs, bushes, and young trees. The age and the magnitude of these pine trees is just amazing. You rarely see that out in the swamp because it is burned on a pretty regular basis about every 10 to 20 years. These old pine trees here, some of them are 75 or 80 years old, even though they're not gigantic. Okay, I just wanted to mention that we're on the edge here, and as we move out into the swamp, the composition of the forest, the makeup of the forest will change. I will be pointing that out. This tree here is a wax myrtle. Myrica cifera is its proper name. It's also called wax myrtle because in the spring it has thousands of little tiny flowers, and every flower is fertilized by some insect, and it develops into a tiny seed, maybe just a 1/16 of an inch in diameter, but it's covered with about an 1/8 of an inch of wax. So hence the name wax myrtle. The wax can be gathered. It can just be stripped away with leaves and twigs and all into a large bucket, take it back to the house, put it in the wash pot, add water and build a fire, and let the fire burn for about 45 minutes. The wax then melts and comes to the surface. The seeds sink to the bottom. You allow the whole mass to cool, then you have a cake of wax on the surface, anywhere from 1 to 4 inches thick. And that wax becomes an instrument that the settlers would use for all their leather work, saddles, bridles, harnesses, their boots, many of their tools, their shoes. They could wax and waterproof almost every tool and every kind of boots and shoes that they wore. The wax was also used to make candles. The wax was also used in the making of soap. So it was a very significant source of wax, and it was almost unlimited. There was always just millions of those flowers and those berries along and along in the swamp, in the understory, particularly along the edge and in the shallow parts of the swamp. It also has insect repellent qualities. If you take these leaves and scrub them, put a little on this ear and this back, this arm and this arm, the insects will leave you alone because it has a strong organic odor. It's a pleasant odor. It's not a repulsive odor. It's a very pleasant odor. The wax was also used in the canning of foods. They may have jars without lids, so it was easy to melt the wax and to make a lid out of a layer of wax in the jars to preserve their food for the winter. We hesitate here for a moment just to look at the kind of growth you see right here, here, and here. These little bay trees, black gum trees, these are black gum trees right here and here. These trees burned in the fire of 55. This whole area here burned in the fire of 55, 1955. So it killed the tree, but it did not kill the roots. The roots were still alive, so when the fire finally went out and the water came back to refresh the land, these live stumps sprouted and new trees grew up. We have one right there. It has 3 trees in it. Here's one with 5 trees in it. Here's one with 3. All along the boardwalk, we will see this phenomena of growth. If its temperature doesn't get down into the root system, if the drought is not that extensive, then the root and the trunks will stay alive. And as soon as the water comes back, it'll sprout and new shoots come up. Some survive, some don't. Those that survive are what we see today. So these trees right in here are old trees. They just have been very, very slow to grow. On these trees, we see a growth of lichens so thick that you can't pull them off. So they're right close on. They almost look like they've been painted onto the bark of the tree. So this is a lichen with only one side, the outside. You can't see the other side of the lichen because it's so thin and so tenacious, so well adhered to the surface of the tree. Lichens are usually found on most trees in the swamp. Lichens are a commensal kind of relationship with the tree. It doesn't hurt the tree at all, even though some people think they do, but they don't really hurt the tree at all. Some lichens are leafy, like this one right here. That's a leafy lichen. Others are shallow, and others are shallow, and some are. Here's some leafy ones coming in here, very gradually filling in. So discolorations will appear all along the boardwalk, throughout the swamp. Here we see a pine tree. Pine trees usually don't have any limbs and leaves down on the bark. They go maybe 90 feet before they even make a leaf. But here we see a pine tree with green leaves coming out of it. Here you see it. There it is, ladies and gentlemen. If you can zoom in on that, that is an example of a vine that grows from the ground up to the tree, and then it grows under the bark. Sometimes it'll come out, but most times it stays under the bark until it gets up here in the light. And when it gets to the light, then it may come out and create a little stem and with 3 or 4 leaves on it. And here it is. This particular plant is called climbing heath, H-E-A-T-H, like the candy bar, the Heath bar. This is a vine that grows from the ground, under the bark, and up into the lighted area. They will go all the way to up 30, 40, 50 feet up, and if you'll notice them, look along the boardwalk, you'll see these green leaves on a pine tree way down here low. Normally it's not there. It's an example of yeah, this is commensalism, where neither party is harmed, and in this case one of them is helped, but neither is hurt. So it's a common relationship. There are a lot of examples of it in the swamp. Around us here we're into a mixed forest of cypress, bays, and black gum, and it's also invaded by a lot of smilax vines growing up. Well, you see them growing out here. And over on this side we see a cypress tree that someone probably 10 years ago bent it over and pushed it under the boardwalk. So the end of it, the top end of the tree, maybe 3 or 4 feet of it, is underneath this boardwalk. A phenomena of growth is the way trees, notice there's not a limb down here on that cypress tree, not a limb, and then pine trees, they're way up there, 40, 50, 60, 90 feet. But here we see a cypress tree with limbs coming out all along the bottom of it here. Even down there close to the ground, and the end of it has already decayed from being submerged in water for so long. So what scientists did was they did some more tests and some more trials, and they found out that the growing tip, the top of the tree, produces a hormone that inhibits the growth of sprouts along the trunk. So it's receiving an inhibitory message most of its life until something happens to the tree, like a fire, or like this is evidence here where somebody stuck it under anything that would interfere with light, anything that would interfere with the light impacting the surface, I mean the top of the tree. Then that cuts off the inhibition and allows growth to occur all along the trunk. And here you see it. So this tree still acts like it wants to grow. So instead of growing vertically, it'll grow horizontally for a while. But the new growth obviously is going to be vertical anyhow. So that's just another of nature's quirks, that it controls the dynamics of the growth of the limbs on the tree. In the water, some of the aquatic plants have adapted to the water so well that water will not even stay on them. Hence they've created a surface that readily sheds any water that gets on it. Below us down here we have the long elliptical leaves of a plant that we call never wet, simply because it will not stay wet on the surface. Let's pour a little water on it and see what happens. Pour a little water. Notice how it immediately disappears. It goes away immediately. Now, if you pull a leaf, if you reach down there and pull off one of them, and we can do it out on the walkway, pull a leaf and look at the back of it, the back of the leaf stays wet all the time, but the top surface of the leaf does not stay wet. Okay. The structure of the leaf on the top layer, the top epidermis, which is just a couple of cells thick, is so tiny, and it's not a flat surface, but it is a rounded surface. There are millions of little tiny bumps, and in between those bumps is a little valley, and then there's another bump. So it's like this, and they're so close together, and water, the hydrogen bonding, the power that keeps water as a molecule is so close together, and that it will not break it. It will not break and run down in the crack between the little balls. We have to see that on a microscope, really, to understand. I mean, conceptualize it. It's so that's why it's called never wet. We stop here to have a look at some of the ferns. There are like 22 different ferns that grow in our swamp. And the one you see here is the Virginia chain fern. Virginia chain fern, because on the back of the leaf, if I can reach one here, on the back of the leaf in the springtime, not here yet, but on the back of the leaf is where ferns produce their, what we call sori, S-O-R-I, sori, which are tiny little, oh, there they are, yes, here there is. And you can see that, see those coloration? Those are thousands of little sori, each of which will open. Each will open and release spores, not seeds, but spores. It's an N, not a 2N. It just has half the number of chromosomes in here. It has to fertilize a female part called the archegonium, and before it makes the seed. So, and these sori are arranged in little chains right along the back of the leaf, hence the name Eastern Chain Fern. This is a small pond cypress that has just grown a few years. It's only about 4 or 5 feet tall here. And notice the leaves. Here's the leaves. That the term for the arrangement of the leaves on the petiole is closely arrayed. Closely. It's very closely arrayed to the petiole. See, they're almost flat with the petiole of the leaf. Compared to this one, this is a ball cypress down here. This is a ball cypress. Here's another one over here. They're little tiny saplings that have just come up, and they're only probably 1 or 2 years old. But see the leaf arrangement? Let me just take one leaf. See the difference in the leaf arrangement? Oh, it fell off. Here it is. That's the difference in a ball cypress and a pond cypress. When they mature, the ball cypress usually grows taller and with great big abutment. The swelling of the bottom of the tree is called the abutment. Pond cypress also has an abutment, but it's not as big as the ball cypress are. They both will grow up to 100 to 115, 120 feet tall, 130. Very, very old cypress trees, when they get very old, they turn flat. Their top in profile, when you look at them in profile, there's no more of this. It doesn't assume that kind of growth. That's typical young trees of any kind. But when they get old, they begin to flatten out, and they exhibit a flat top. That means that tree is close to 100 years old, if not more. Very, very old. So that's the main difference between them. Okefenokee means the land of trembling earth. And the reason it's called the trembling earth is because of the gas that is produced in the peat bed. We've discussed this before, and you've seen some containers containing the layers of the swamp, and gas was one of them. So here we can see it come to the surface. If we take a pole and push down into the peat bed, we see bubbles. Now there it comes. There they come. Here's some more. Here's some more. So there is plenty of gas under there. The gas is produced by that Methanococcus bacteria that in its metabolism it always has some waste gas. In fact, it has two, methane and carbon dioxide, and both of which is in that gas that comes to the surface. Sometimes it gets caught in the peat and it floats the peat up, and eventually through succession it develops a community that lives on it. And that's why we call it the land of trembling earth, because if you walk on it when it's very young, you might go through, or it might just act like a pillow or a sponge to you. But you don't worry about it. You won't go too far. You're forked, you'll stop. In our woody area of the swamp, we have three kinds of bay trees: a red bay, a white bay, and a loblolly bay. Three of them. We have two of them here. This is a loblolly bay here, a loblolly. The leaves are almost serrate. If you look at it closely, you can see the tiny serrations on the edge of the leaf, the little tiny bumps, teeth-like. And some insect has been feeding on it also. The loblolly bay is almost an evergreen. It's almost evergreen because it will have green, yellow, and orange leaves all at the same time. The orange and the reds and anything that's not green is in the process of dying. And as it dies, chlorophyll is the first thing to go. So the green disappears and the yellows and the golds begin to appear underneath, which are all within this little thin leaf here. There's probably 6 different layers of tissues inside that leaf. And the pigments are always there. They're just masked. They're just overgrown by the chlorophyll. But when the days begin to get shorter, and they have, as the days get shorter, it ceases to produce as much chlorophyll, and it also begins something else. It begins the process of shedding. In order to shed a leaf must produce a hormone called abscission, and it forms right here at the base of the leaf, right here at the base of the leaf, and it becomes very weak, weaker and weaker, day by day, slowly, until all the green is gone, the red is gone, the gold is gone, and they finally, the abscission layer becomes so thin, and when the wind blows just a little bit, these leaves fall off. And that's what this causes them to shed leaves, is the formation of the abscission layer. If it doesn't produce an abscission layer, the leaves will fall off. The leaves will never fall off. They'll just die and hang on. You know, I'm sure you've seen it before. Limbs hanging over, dead, and every leaf on it is brown. It's brown because it's dead. But it's only there because it did not form an abscission layer. In order to shed, it must do it by a hormone that forms a special weak layer at this attachment right here, that little spot. It has to form there, between here and there. And that's what makes them shed. And that's why when limbs break off, trees get broken, the limbs may still be hanging on, but they're dead, and the leaves don't ever fall off. This is the red bay. This is the red bay. This is the bay that can be used to cook with. This is the bay, if you take it and crush the leaf, you can smell the aromatic odor that is used as a bay leaf that we put in soups and stews. And here, that's it. The early settlers would pick these, hang them in the smokehouse or in the dry place, in a dry site, until they dried up, and then he put them in a jar and keep them over the cooking for the right time to use them in the soups or stews. So this is the red bay. Red bay. Persea bourbonia. Persea bourbonia is the proper name. On this side of the tower, we see a growth of soap bush. Soap bush. Simply because if we take the leaves and scrub them vigorously with a wet hand, you might make a lather. It's extremely rich in the springtime of the year. This late into the winter time, it may or may not lather, but we've tried. We'll see what we can do. Get us a handful of the leaves here, and a few more that we can pick readily. This is a good growth of it, and it'll be really rich in the springtime. And see if we can whoop up a little lather here. You have to put some elbow grease in it here in the wintertime when there's not much soap there. There it comes a little bit. There it is. You have to break that cell membrane to release the chemical that makes it lather like this. So here we see it. We see the dead leaves and a little bit of foam. In the spring of the year, this is just very luxuriant. It foams all over your hands. But here in the winter, it's a little bit thin. Ladies and gentlemen, here we are about 40 feet off of the ground, and at this level, in the cypress trees, which are all around us right here, and they are covered, most of them are covered really, with Spanish moss, which is not a moss at all. It's a bromeliad. It's like some of the flowering plants that you have at home. This plant grows in 3 different forms in the swamp here. There are 3 different kinds of Spanish moss. One of them is called ball moss. Ball moss, and its common name, recurvata. Ball moss is the genus recurvata. It's because the leaves all curl inward like this and form a spherical structure. But it's still a bromeliad. Just like the bromeliads, in the grocery store that you buy. And if you look at the leaf, look at any leaf of a bromeliad, even with a hand lens, you can find little tiny scaly growths on the surface of the leaf. That's the way this plant gets its water. As it rains and it runs down the trunk and into the Spanish moss, as it goes by those little tiny holes. There's a tiny little hole at the base of every branch of Spanish moss. And in the meanwhile, when the water's running down, it's carrying the minerals from the decaying bark and twigs and leaves above it. So here it is. Here it is. And we see the tiny little leaves all curled up. And if you look at it with a hand lens, with a little magnifying glass, you will see that it has tiny little cellophane, almost cellophane-like leaves. Maybe we can do this here. We'll try. Underneath that gray area, we'll try to peel off the outside. Yeah, there it is. Can you see that? Can you see that black hair-like structure there? That is, it's called a stele, S-T-E-L, stele. It is a botanical structure. It's a part of the plant. It's a living part of the plant. But the other part I peeled off with the fingernails of my thumb and index finger and pulled it away. So that's what's inside. Now, if you collect Spanish moss by the bucket, by the barrel, and you take it back to the house and you put it in the wash pot and you light off a fire underneath the pot and boil it for just a few minutes, maybe 20 or 30 minutes, so that it kills all of this surface living tissue. It kills the surface. If you dip it up and down in the water, it washes away the dead stuff, and the only thing that's left is the little fibers. And when you have 10 million of those little fibers, it makes a wonderful pillow, cushion, mattress, any soft area you like to pad. This makes good padding because it's very elastic. It bends. It does not stretch well, but it's very flexible, and so it's like a pillow. It comes back and it resumes its shape. Once it's deformed, it comes back. There it is. There it is. There it is. Can you see that one? Not on my shirt. Maybe on that shirt.
Yep, I can see it.
Okay. All right. So this is what the early settlers would use for pillows and cushions and mattresses. During World War II, this and sphagnum moss were both used in dressings. Back then, we didn't have all the facilities and kind of dressings to dress wounds of war. So that was another use for it.